Good morning everyone. Welcome back. I'll start new chapter and the name of the chapter is circle. A circle is the path of a point which moves in a plane such that it remains at a constant distance from the fixed point in a plane. So the definition tells you that circle is the path of a point in a plane which moves such that the distance remains constant from the fixed point in the plane. So let's consider a fixed point and a point at certain distance, say P. If this point P moves around the fixed point such that these distances remains constant, the figure obtained is called a circle. It is the path of point in a plane which moves such that the distance from the fixed point always remains constant. This fixed point is taken as the center of the circle, and the distance between center to the point is called radius. Second technical term, important term related to circles or circle is called interior of a circle. The collection of all points inside the circle is known as interior of the circle. So you have a fixed point and a point is moving around the fixed point such that distance remains constant. Collection of all points inside the circle is called interior of the circle. Second one is exterior of circle. Collection of all points outside the circle in a plane is known as exterior of the circle. So the first important term for circle is center, and the point which is moving around in a fixed distance, the distance is called radius. Collection of all points inside the circle is called interior of the circle. Collection of all points outside the circle is known as exterior of circle. Now the important term is called chord of a circle. Chord of a circle. A line segment joining any 2 points of a circle is called chord. Circle with center O. Distance from the center to point is known as radius. Now chord, a line joining, a line segment joining any 2 points on the circle is known as chord. A and B are 2 points. A line segment is joining these 2 points, and this line segment is called chord. We also call it as length of the chord. Length of the chord. Now you have diameter of circle. A chord of a circle which passes through its center. A chord of a circle which passes through its center is called diameter of the circle. fixed point, a chord passing through the center of the circle is called diameter, and diameter is the longest chord can be drawn inside the circle. So if you look at the diagram here, P is the center of the circle, A is a point, and distance between center and the point on the circumference is known as radius. Distance from center to point on the circumference is radius. So diameter is equal to twice of radius. Next definition is secant of a circle. Secant of a circle. A line which meets a circle in 2 points. A line which meets a circle in 2 points is called secant of the circle. So you have circle with center O. A line which is passing through 2 points of the circle is known as secant. Difference between chord and secant. Chord is the line segment joining 2 points, and secant is a line joining 2 points of the circle. Arc of a circle now. Next one is arc of a circle. A continuous part of circle is called arc of circle. You have a circle with center O. The continuous part of a circle. So we start a point E, and this continuous part of the circle AB is known as arc, ARC, and it is represented by a symbol. When you have AB and curve at the top, we are talking about an arc. Now you have minor and major arc. An arc less than 1/2 of this whole arc. An arc less than 1/2 of the whole arc of a circle is called minor arc. So you draw a circle with center O. If you have an arc drawn which is half of the whole arc, it is known as minor arc. An arc which is more than half of the whole arc is called major arc. So we start from A and go around the circle to reach point B. This part of the circle, arc of the circle, is more than half. That's why it is known as major arc. Minor arc, which is less than half of the whole arc. So this AB lower part is less than half of the whole arc, and upper part is more than 1/2 of the whole arc. So upper one is called major arc, lower one is called minor arc. Semicircle. Semi means half, and half of the circle is called semicircle. When PQ is diameter, then both arcs are equal to each other is called semicircle. So suppose you have a circle with center O. AB is the diameter. Arc AB of the circle is equal to arc AB of the circle in the lower one. And both the arcs are equal, so each part of circle is called a semicircle. Circumference. The whole arc of the circle is called the semicircumference. The whole arc of circle is called circumference. So these are important terms you need to go through from the chapter circle. Then you have theorems related to chord. Only theorems to be learnt. Proving is not needed, but still we can prove it from the book. The first one, theorem number 15.1, and it is very, very important theorem. Theorem tells you that straight line drawn from the center of a circle to bisect a chord which is not a diameter is perpendicular to the chord. So see what this theorem tells you. Circle. Mark 2 points on the circumference A and B. The line segment joining AB is called chord with center O. Theorem tells you that the line drawn from the center to bisect the chord is perpendicular to the chord, means that this angle you have to prove it as 90 degree, and it's easier to prove. We write this intersection as M, we join AO and we join OB. When you have joined AO and OB, prove these two triangles are congruent. And look at the proving. In triangle AMO and triangle BMO. The first one, AO is equal to AOB. They are radii. Radii of a circle is always equal. Second one, AM is equal to MB, because this line OM is bisecting the chord. OM bisects the chord. Third one, OM is equal to ON. Therefore, triangle AMO is congruent to triangle BMO. Side, side, side. Rule of congruency. And once you prove these two triangles are congruent, corresponding sides and corresponding angles are equal. Therefore, angle AMO is equal to angle BMO, CPCT. Once you prove this, then you write angle AMO plus angle BMO is equal to 180 degree. Angles on a straight line. Angle AMO plus these two angles are equal, so replace BMO by angle AMO, 180 degree. Therefore, twice of angle AMO is equal to 180. angle AMO is equal to 180 divided by 2, which is equals to 90 degree. And once you prove angle AMO is 90 degree, therefore line OM is perpendicular to AB. Therefore OM is perpendicular to AB. So line drawn from the center to bisect the chord is always perpendicular to the chord itself. Theorem number 15.1. Similarly, you have theorem 15.2. Similar, perpendicular to chord, from the center of a circle bisect the chord. So look at theorem number 15.2. And you have to apply these theorems in the exercise. Circle with center O, draw chord AB. Theorem tells you that perpendicular drawn from the center to the chord bisect the chord. So we write this point as M. You need to prove AM is equal to MB, because this perpendicular is dividing that chord in equal halves. So we join AO and OB. Prove these two triangles are congruent in triangle AMO and triangle BMO. First one, AO is equal to OB, radii. Second one, angle AMO is equal to angle BMO. OM is perpendicular to AB, means it makes 90 degree angle with the chord. Third one, OM is equal to OM. Therefore, triangle AMO is congruent to triangle BMO. And you have side, angle, side. Or you can write RHS, right angle hypotenuse, side. Once you prove these two triangles are congruent, corresponding sides are equal. Therefore, AM is equal to MB, CPCT. So perpendicular drawn from the center to the chord always bisect the chord in equal halves. Similarly, you have theorem number 15.3. Equal chords of a circle are equidistant from the center. And look at this proving of the theorem. Draw two equal chords AB, CD are two equal chords. From center we draw perpendicular. Write it as M. From center you draw perpendicular. Write it as N. Join AO and join OD. You need to prove OM is equal to OM. Equal chords are equidistant from the center. Distance between center and the first chord is equal to distance between second chord and the center. So in order to prove it, we take these two triangles and prove it they are congruent in triangle AMO and triangle CNO. First one, AO is equal to OD, radii. Radii of circle is always constant. Second one, angle ANO is equal to angle DNO. 90-degree each. Line drawn from the center to the chord is always perpendicular. Third one, AN is equal to DN. Reason is chord AB is equal to CD. Chords are equal. Line drawn from the center to the chord divides the chord in equal halves. Bisect it. So AM is equal to CD. Therefore, triangle AMO is congruent to triangle CNO. It is side, angle, side, rule of congruency, or RHS, right angle, hypotenuse and side. Once you prove triangles are congruent to each other, corresponding sides are equal. OM is equal to ON, CPCT. Corresponding parts of congruent triangles. Therefore, equal chords are at equidistant from the center. If chords are equal length, distance from the center are always equal between the chords. Similarly, you have converse of theorem 15.3. Chords of a circle that are equidistant from the center are equal. So if these two distances are equal, then the chord AB and CD will be equal in length. You need to prove triangles are congruent, and only this part will change. This part will change. ON is equal to ON. Chords are equidistant from the center. Therefore, triangle ANO is congruent to triangle CNO. And once you prove these two triangles are congruent, AN will be equal to DN, CPCT, corresponding parts of congruent triangles. Similarly, we can do on this side like this and prove these two triangles are congruent again. So you have NB is equal to NC, CPCT, then add it up. AN plus NB is equal to DN plus NC. AN plus NB is AB, DN plus NC is DC. Chords are equal in length. If chords are equidistant from the center, the length of the chords are always equal. The last theorem, there is one and only one circle passing through three known collinear points. So this theorem tells you that only one circle can be drawn through three non-collinear points. Suppose you have A, B, C, non-collinear points. Only one circle can be drawn and the circle will pass through ABC. So you join, you get a triangle. Draw perpendicular bisector of this, perpendicular bisector of other one. Intersection is the center of the circle. Then you draw a circle so that it passes through ABC. So remember, one and only one circle can be drawn through three known collinear points. So these are theorems you need to remember from chord properties of circle. First one, line drawn from the center bisect the chord in equal halves is always perpendicular. Second one, the perpendicular drawn from the center bisect the chord in equal halves. Third one, equal chords are equidistant from the center. And fourth one, when chords are at equidistant from the center, the length of the chords are equal. So please go through the theorem. It's very, very important. You will be needing it in exercise. Thank you very much. Stay safe.